So for 2.4 part 2, we're going to still be working with the chain rule, so still working with functions that are inside other functions, adding in a few complications like trig functions and functions with inside of other functions that are also in chain rules or product or quotient rules or other rules mixed in with the chain rule. So if we have y equals sine squared x, find y prime, it's asking us to find the derivative. So we have to set up our chain rule, because I'm not sure if you all realize this, but sine squared x is really this. Not just the x being squared, but the whole function of sine squared. So this is just rewriting, so it's still y. And then we're going to set up our chain rule. Now that we know we have the chain rule, we know we have a composite function, we have to use the chain rule. So our inside function is sine x, and the outside function is u squared. The derivative of the inside function is cosine x, and the derivative of the outside function is 2 times u to the first. Then the derivative of the whole function, using the chain rule, is u prime times f prime of u to the first. That's not a u prime, that's u to the first. So substitute in and rearrange. So I'm going to put the 2 first, and then cosine of x, and then u, remember, was sine x. And we don't actually have to remember it because we've written it. Please write your steps out so that you don't lose place of where you are. And that's all we can do. We can't simplify it anymore. So that is our final answer. If we have something like this, where we have a quotient inside of a power, then we have to do the quotient rule inside of the chain rule. So our inside function is 3x minus 1 over x squared plus 3. And the outside function is u to the second power. To do the derivative of the inside function, so I'm going to work on u prime, I have to set up a quotient rule. So here's another u, or let's do low and d high. So low is x squared plus 3, and high is 3x minus 1. D low is 2x. D high is 3. So the derivative of our quotient, u prime, is low d high minus high d low, all over low, or low squared. Simplifying that, in the numerator we have 3x squared plus 9 minus, parentheses to remember to distribute our negative, 6x squared minus 2x, all over x squared plus 3 squared. Continuing to simplify, 3x squared plus 9 minus 6x squared plus 2x, all over x squared plus 3 squared. Do not multiply out the denominator. And then we have combining like terms, negative 3x squared plus 2x plus 9, all over x squared plus 3, quantity squared. We try to factor this, but it doesn't factor. You should always try to see if it might cancel with this denominator. Okay, back up here, f of u is u squared, so what's f prime of u? Using the power rule, 2 times u to the first. So our chain rule to get the derivative of our whole function is u prime times f prime of u. And u is this whole big function. So my final answer, 2 times u over x squared plus 3 times negative 3x squared plus 2x plus 9, all over x squared plus 3 squared. Okay, I lied, it's not the final answer. Something that we can do that's obvious here is multiply the denominator together. So we'll have 2 times 3x minus 1 times negative 3x squared plus 2x plus 9, all over x squared plus 3 to the third power, just multiplying straight across. X squared plus 3 to the first times x squared plus 3 to the second would be x squared plus 3 to the third. So that's our final answer. There's no other factoring to do, and it's not helpful to multiply things out, so just leave it. The only time you want to multiply things out is if you have something that's a subtraction or addition sign in the problem, and then you want to be able to multiply it out so that you can combine your like terms and possibly get to something that does factor. So that's the chain rule with a quotient rule inside of it. Here's another one that we're trying to figure out what's our inside and what's our outside functions. Remember, this power of 2 only applies to the x. So our outside function is cosine of, and then 3x squared is the inside function. That's another way to write what this means, but we don't write it like that, so you just need to know that. It's implied that you should know that that 3x squared is the inside function. So our inside function is 3x squared. Inside function is 3x squared. Outside function is cosine of u. The derivative of the inside is 6x. Derivative of the outside is negative sine of u. So the derivative of the whole function using the chain rule is u prime times f prime of u. Put u back in. So we have 6x times negative sine of 3x squared. And for trig functions, you always write negatives first, numbers second, variables next, and then the trig function at the very end. So there's your final answer. The chain rule can be used with functions that have more than one inside function. You just multiply the derivatives of all the separate functions together. Remember to substitute the functions back in so the final answer has only x's in it. So if you're going to use substitutions, make sure that your final answer doesn't have any substitutions. So instead of using u and f of u and then maybe another function like g of f of u, we're just going to reduce it down to variables. We're going to do an inside function, and then the next inside function, and then the next inside function. So u is the very, very inside one, v is the middle one, and w is the very outside function. Let's think about what's going on here. We've got this power of 3, which is on this whole thing. So that's the very outside function. Then we've got 5x plus the square root of something. That's the middle function. And then the very inside function is the x squared plus 3. So if you think about the order that you would do this in if you knew what x was, think about evaluating this using the order of operations. If we knew, let's say we knew x was 1, just as an example of how to figure out which function is the inside and which one's the middle one and which one's the outside one. If you knew x was 1, first you do 1 squared minus 3 and get that answer. So that's your very inside function. It's like the very first thing you would do if you knew what x was. And then once you get that answer, what you would do with that is the 5x plus the square root of that inside function. And then finally, you would take that function, that answer that you just got, that v, we're calling it v, this whole inside, and then to the third power. So very inside is u, middle is v, and then very outside is w. Then you take the derivative of each piece. Now the u and the v and the w we've just randomly chosen. Mathematicians use them a lot, and the u and the v might get complicated, so you can choose other letters if you want, but that's just what I'm going to be using. So if u is x squared minus 3, u prime is 2x, so that's the derivative of the very inside. Then I need the derivative of the middle part. 5 times x, the derivative of 5x is just 5. And I'm going to rewrite this, 5x plus, instead of u to the, in a square root, I'm going to write u to the 1/2. So the derivative, because this is still v here, the derivative of 5x is 5, plus, and the derivative of u to the 1/2 is 1/2 u to the negative 1/2. So substituting u back in, it's 5 plus 1/2 x squared minus 3 to the negative 1/2. And then w, the derivative of w, since it's v cubed, is 3v squared. Substituting back in 3 times v squared, v is 5x plus the square root of u squared. Now, can you square each one of those? Of course not. You'd have to use FOIL, and we don't want to multiply things out unless we have to. But notice this has a letter in it still, so w prime is not done being dealt with. We have to substitute back in all the letters so that we have only the letter x left. So we have 3 times the quantity, 5x plus, and then the square root of u, and remember u is x squared minus 3. So x squared minus 3. So now we've got all of our derivatives, and we can just multiply them all together. Derivative of the inside times the derivative of the middle times the derivative of the very outside. So our final, not our final answer, but our final setup is 2x times, that's the u prime, and then 5 plus 1 half x squared minus 3 to the negative 1 half times. Notice they're all multiplied together, right? So use those parentheses. Don't be skimpy on your parentheses. And then this has a fraction in it. Technically that is 1 over 2, and then a negative 1 half means it was a square root in the denominator, x squared minus 3. Oops, that's not what I meant to write. So if you're trying to match this with what the book has, they probably got a common denominator with that too, but we're just going to leave it like that. Another thing that students often struggle with trig functions is that order of operations. So let's use that idea of if we knew what x was, what order would we do things in? So we've got y equals 3 cosine squared 4x. The reason we're doing this is to figure out what the inside function is and then the next function and then work out from there. So if we knew that x was pi over 4, the first thing we would do is do 4 times x. So if I'm evaluating, the first thing I would do is the 4 times pi over 4. So this part is my inside function. And then, once I get that answer, which happens to be pi, so I have 3 cosine squared of pi, then the next thing I'm going to do is that. So what that means is, remember the cosine squared pi really means this. They just don't write it. You know, the mathematicians are lazy and they don't want to write parentheses if they don't have to. But they will write them when they're necessary. In this case, they're not. If you write a 2 there, it means this. So the next function inside is this to the second power. Then what we would do, so cosine of pi in your unit circle, pi's over here, the ordered pair is negative 1, 0, cosine is the first number, so that is negative 1. Now in the order of operations, what do you do next? You have to do squaring next. So this part, we're going to do this part next. So the squaring is the next part, and you get 3 times 1. And then finally, your last step is that multiplying. The multiplying of the 3 times the 1. Okay, so our final answer would be 3. The reason we did this is not because it's going to show up like that in your calculus book. I'm not going to give you a value and ask you to plug it in, hardly ever, except if you're trying to find a y value, which is part of a bigger problem. We need to do this so that we know what order to take the derivative, where our inside functions are. So inside function is 4x, that's going to be the u. And then the next inside function is the cosine of u. Then the next one is the inside function, we call it v to the second power, and then that function we'll call w, and it's going to be 3 times w. So we just work out to the outer edge to take the derivative of that. So our inside function is u, 4x. Then the next function, the next thing we're going to do is cosine of that u. This is the order we would evaluate it in, so it's the order we have to set up our derivatives. Then the next function next thing we would do is take that cosine u and square it. so we're going to do v squared. And then u, v, w, x, y, let's use z because x and y are kind of reserved for x and y. The outside function is 3 times the answer we got for w. Now if you want, you can combine these two and just make this 3v squared. So we could do that. Why don't we? Either one would be correct. We'd end up with the same answer. So our chain rule says, now that we've got our functions set up, they're like nesting dolls, like those Russian nesting dolls. U prime is 4, v prime is negative sine u, but we want to put u back in, so it's negative sine of 4x. Please remember you always put the original function back in. You never put a derivative into the derivative of another part. And then the derivative of w would be 3 times 2v to the first. So it's 6v, but v has to be back substituted. So v was cosine of u, so we have 6 cosine of u. And that's still not all the way back to the original letter, which was x. So we have 6 cosine of u, which is 4x. So our final derivative, not our final, the final setup for our derivative is u prime times v prime times w prime. Simplifying, you put negatives first, constant second, and 4 times 6 is 24. Then your trig functions, cosine 4x, sine 4x, or sine 4x, cosine 4x. Now that's our final answer. There's your homework. I think I changed it, so let me adjust it here. I know I didn't adjust it on the previous video. So we're going to be doing $43 to $51 odd. Oh wait, nope, that's Monday. Sorry. Yeah. Okay, 23 to 33 odd, and then 43 to 51 odd. So that is due the next time we have class. Just a little adjustment. If you already finished the previous assignment up to 29 or 31, whatever I had on the previous one, that's fine. Just continue on. Have a great night.